Example, differentiate the following with respect to x. Roman 1. Y equals to 2x. Y is the function, therefore f of x equals to 2x. What else? From our formula, the first principle of differentiation, we have this f bracket x plus change in x. Therefore, we can write f bracket x plus change in x. Therefore, simply, we substitute this x plus change in x where there is x. Therefore, you'll have 2 bracket x plus change in x. This can be also simplified much as 2x plus 2 change in x. What are we going to find? We are going to find the slope or the derivative of the function. Change in y of change in x equals to how much? From the first principle of differentiation, that change in y of change in x under the certain limit of change in x should approach to 0 equals to f of x plus change in x bracket minus f of x, then you divide it by change in x. Therefore, the value of f of x plus change in x equals to this much, 2x plus change in x, 2 change in x. Then you subtract, remember the brackets, you subtract what? You subtract 2x. Divide by change in x. After there, you'll have 2x plus 2 change in x minus 2x. You divide it by change in x. Then, these 2x and 2x will cancel. Therefore, you'll have 2 change in x. You divide by change in x. Therefore, change in x and change in x will cancel. You'll have 2. Therefore, if you differentiate y equals to 2x, the answer is 2. If we find the slope of y equals to 2x, the answer is 2. Therefore, let us move to Roman 2. Roman 2, you have to find the derivative of y equals to x squared. Derivative of y equals to x squared. Therefore, y equals to the function, f of x is equal to y, therefore you'll have x squared here. Again, from your formula of the first principle of differentiation, you have f of x plus change in x, therefore you write f of x plus change in x, then brackets, equals to, you substitute x plus change in x where there is x, therefore you'll have x plus change in x bracket square. You can open the bracket to expand it as this x plus change in the x bracket, x plus change in the x bracket, you multiply x and x will give you x squared, x and change in the x, simply because change in x is as you say a, therefore this is a single term, therefore you'll have x change in x plus x change in x plus change in x bracket square, as I said earlier, that change in x equals maybe to a. Therefore, you collect the like terms, x squared plus 2x change in x plus change in x, then bracket square. This is the value of f of x plus change in x as our question is asking. Therefore, also, what are we going to find? We are going to find the slope. What is the slope? Change in y of change in x. Then from first principle of differentiation, again from first principle of differentiation, first principle of differentiation as change in y of change in x under the limit of change in x approaches to 0 equals to f of x plus change in x. You subtract what is known as f of x, you divide by change in x. After that, you substitute your values, that f of x plus change in x equals to x squared plus 2x change in x plus change in x squared. Therefore, you'll have x squared plus 2x change in x plus change in x bracket square. You subtract, remember the brackets, you subtract what? You subtract x squared. Then you divide it by change in x. Therefore, after that, you open the bracket, you'll have x squared plus 2x change in x, you plus change in x bracket square, you minus x squared. Then you divide it by change in x. After that, x squared will go, will remain with what? 2x change in x plus change in x square divided by change in x. From here we have change in x, change in x. Then therefore we can factor out change in x. You'll have 2x plus change in x bracket. You'll have change in x. Therefore change in x and change in x will cancel. Remain with 2x plus change in x. You remember our limit? Our limit is change in x always approaches to 0. Therefore, you'll have 2x, put 0 where there is change in x, then your slope is 2x. Your slope is 2x. Therefore, if you want to find the derivative of y equals to x squared, the answer is 2x.